Ahoy guys, this is Mr. C with your triangle inequalities lesson. I'm going to bypass some of the extra stuff in the notes that we've already covered in other lessons just to get you the things that you need so you can be successful on the test. I'm so sorry for not posting this earlier. I forgot to record during class today. So let's get started so we can get this uploaded quicker. So the triangle inequality states that the sum of any two sides of a triangle must be greater than the measure of the third side. So really what that's saying is this one. This is right on the money right here. A plus B is greater than C. That means the side length of side A plus the length of side B, if I put them together, it'll be longer than side C. I have a trick here where we can kind of bypass these two except in one or two special cases. If I assign the longest side the letter C, then everything's going to work out really well. And this is really the only one that we would have to consider. The shorter two lengths have to add together to be longer than the longest length. Think about it. If this is my longest one on these two other inequalities, if the longest side is C, then it's automatically going to be greater than the other length. Even adding it to other stuff is just going to make it bigger. So I always like to make the longest length C when I'm assigning them. Okay. I do have to make sure it's satisfied for all three, and that's in a very special case, and I'll show you that in a little bit. Okay. So as soon as you know that the sum of two sides is less than or equal to the measure of the third side, you know that the sides will not make up a triangle. It would be impossible. Okay? And what this means is when it's impossible, you'd have your long length down here. If you added up A plus B and it wasn't bigger than C, essentially you'd have a triangle that's not really a triangle. It would look something like this, where there's this big gap inside because length A and length B are not big enough to get up to make the peak of the triangle. Right? We'd have some very, very weird, bizarre shape. So in this particular case, A plus B would not be bigger than side C. We say it has to be all three sets must satisfy the rule. Well, think about it. If I did C down here on the bottom plus A, of course it's going to be bigger than B. Right? It would work for two of them, but it wouldn't work for the one that's the most important. So I always just assign the longest side has to be C. What I'm going to do now is I'm going to bypass some of these other notes because it's stuff we've already talked about. Okay? And it's stuff that's important to lead to getting to this point, but you already know this information. I want to do some example problems. I'm actually going to skip to the homework side. Okay? So take a second, push pause if you need to turn to the homework page, and then let's get playing once again. Here we go. I want to show you how this works. So what I do is I just go ahead and assign, we're going to see, well, determine the lengths of the sides if they form a triangle. I'm going to go ahead and put A is the first one, B is the second. It doesn't really matter which one is assigned A or B, but C, if you put it as the longest one, that formula is going to help you a lot. Where we did A plus B is greater than C. If A and B add together and they're bigger than C, it's going to work. 3 plus 4.5 is greater than 5.75. So I'm going to add 3 and 4.5, and I will get 7.5 is greater than 5.75. So that means that the two short sides, when I add them up, is bigger than the leftover side. So I know right away this triangle is going to exist. I should check the other ones, and I'm going to model that for you too. I'm going to put them right here, and I'll erase it in a minute. But look what happens. When I do B plus C is greater than A, look what happens with my numbers. B is 4.5, and then C is 5.75. Letter C just by itself is already big enough to take care of the job. And we're never going to have negative values on a triangle because we can't have that. If that's the case where it's a negative length on the side, that triangle is not existent. Right? We can't have a triangle down here that says negative 102. That doesn't make sense. Okay, so we know right away, I don't even have to continue adding. This alone will do the job. And then the other part is if I do A plus C being greater than B, the same thing happens. C is 5.75, and that alone is already big enough to take care of the 4.5. So that's Mr. C's little pro tip for the day, is if you assign the biggest length to letter C, you will know almost instantly if it's going to be a triangle or not, because the problem becomes the two short sides not being long enough. Okay, we don't want a triangle to end up forming some other crazy picture. So if the two short sides add up and they're bigger than the other one, that'll do the job. Okay, let me get rid of this so I can model 2 and 3 for you. So let's do Mr. C's same trick. A plus B is greater than C. Mr. C says, put the longest side as letter C, and we'll know right away. So this one's going to be letter C, it's 46. If I put A and B, it doesn't matter which one I assign A and which one I assign B. I'll flip-flop them just so you can see. Addition's commutative. It doesn't matter which one I assign A and B at that point. A is going to be 24. B is going to be 20.7. And I need to see if that's all greater than 46. Okay, that was a terrible greater than sign. Sorry, guys. If I add up these two over here, 24 and 20.7, I'm going to get 44.7. Is that bigger than 46? No way. Because I have one of these that doesn't work, I know right away that this is not going to be a triangle. Not a triangle. I'll just draw the picture of a triangle. Guys, this is what would happen on this example. My C is 46, right? Then I said letter A is 24, so that's a little longer. And then B is 20.7. I'm going to get some wonky shape that looks like this. And that's not real. It's not a polygon. It's not closed. It has to have all the sides that touch at a vertice. This one will not make it. It's too short. It won't come together. I like to think of this almost kind of like windshield wipers in a car. If I put these windshield wipers down, I'm going to have the little gap here, right? That's not going to make a triangle. It's going to make something ridiculous. Okay? Get rid of that so we're not confusing each other. So this last one, we'll do the same thing. Mr. C's trick. Make the longest one letter C. If you do that, you'll know right away if it can be a triangle or not, because you're comparing the two littler ones. The two little ones, the two little legs are the ones that matter. Okay, we have to see if those work. Let me just do A, then B. Those ones don't matter as much as to what the label is, and C. C matters. C is 29, and A plus B has to be bigger than 29. So we do 11 plus 16. Is that bigger than 29? I don't think so. It's going to give me 27. 27 is not bigger than 29. So unfortunately, I'm going to have another sad face. This is not a triangle. Okay. There is one opportunity where Mr. C's triangle will not work. okay, when I assign the longest side as C. What if I have an isosceles triangle? If I have an isosceles triangle where these two sides are twins and the bottom is lower, I can't assign C as this one. I can, but my thought process unfortunately gets debunked a little bit. So this one, you would have to go back and use all of these guys. You just have to assign them their own letter. I'd have to make this side A, this one would be B, and this one would have to be C. And then I'd have to test it all 3 times. So let's test it. Let's see if Mr. C's isosceles triangle is in fact a triangle. I can do A plus B is greater than C. I can do A plus C is greater than B. We're just comparing all the sides. Then B plus C is greater than A. So let's plug and chug here. A plus B, that's 9 and 9. I know automatically that's going to work. Bigger than 4. 18 is way bigger than 4. We're in good shape there. A is 9, C is 4. 9 plus 4 is 13. B, let's see what B was. 9. 13 is bigger than 9. We're in good shape. Let's check it one more time. 9, oh, yep, plus 4 for B. That's the B side. This one is greater than 9. 13 is greater than 9 again. So because that one worked, this one worked, and this one worked, Mr. C's quick example triangle is in fact a triangle. If one of these did not add up to be greater than the number that was being compared to, we would have to say no, it's not a triangle. Okay? Friendos, the rest of these problems down here I think would be really good and really wise for you to look at, 9 through 14. These other ones are good too, don't get me wrong, but I think these ones are the best bang for your buck in this special page right here. Okay? Guys, I hope this helped. All the other stuff you should have been able to take care of already, so not a big deal. Okay? So I hope this helped. Thanks for watching, and I'll see you guys soon. Bye-bye.